So after the last videos, we know how to take derivatives of something of the form f of x equals x to some power. But what do we do if we want to take the derivative of something like f of x equals x times e to the x, or sine of x times cosine of x? To do that, we have to come up with another method, and we're going to call that the product rule. So that's what we're going to look at in this video. We're going to come up with a way to deal with finding the derivative of functions like this. So to do that, unfortunately, we're going to have to go back to our limit rule of the derivative. But first, let's just say that we're given some generic function, f of x is equal to some function of x, let's call it g of x, times another function of x, let's call it p of x. So f of x equals g of x times p of x. So we remember from the limit definition of the derivative that f prime equals the limit as h goes to 0 of f of x plus h minus f of x all over h. So let's go ahead and rewrite this in terms of what we know. So we know that f of x plus h is just going to be equal to g of x plus h plus p of x plus h times p of x plus h, and we know that f of x we're given is just g of x times p of x. So let's put this into our limit definition of the derivative. So we know that f prime of x equals the limit as h goes to 0 of g of x plus h times p of x plus h, p of x plus h, minus g of x times p of x. And that's all going to be divided by h. So what we have to do now is kind of come up with a clever way to get around this, and for now, just to save some space, I'm going to stop writing the limit over there, but just know that it's actually there. So we're taking the limit in each step of this. So let's go ahead and play with the numerator a little bit, and what I'm going to do is I'm going to write down what we have so far. So g of x plus h times p of x plus h, and now I'm going to add and subtract a g of x plus h times p of x. And I'm going to run out of room here, so bear with me. So I'm going to add another g of x plus h times p of h, or p of x, back on. And then we'll have minus g of x p of x. And then this is all going to be over h. So all over h. Okay, so let's go ahead and factor out a g of x plus h. So doing that, we'll get g of x plus h, and then we're going to multiply that by p of x plus h minus p of x, and then I'm also going to factor out a p of x. So then that'll give us plus p of x, and I'm running out of room here again, p of x times g of x plus h minus g of x. And that's all going to be divided by, h. So in that step, all we did was we factored out g of x plus h over here, and that's what gave us this part right here, and then we factored out a p of x from this side over here, which is what gave us this. So let's go ahead and continue. And what I'm going to do is I'm going to go ahead and break up this fraction. So that's going to give us g of x plus h times p of x plus h minus p of x over h plus p of x times g of x plus h minus g of x over h. Alright, and I'm going to simplify this. Actually, I'm just going to rewrite it a little bit more. I'm not really going to simplify it yet. So then we'll have g of x plus h times p of x plus h minus p of x over h plus p of x times g of x plus h minus g of x all over h. And I think you might be able to see where I'm going at this point, but if you don't, then that's okay. So now what we're going to do is I'm going to go ahead and actually show that show that we're taking the limit. And actually, this whole time we should still be taking the limit, but I was just trying to save some space. So I'm going to rewrite that. So we'll have the limit as h goes to 0 of g of x plus h times p of x plus h minus p of x all over h. And then if you recall, we can split up limits when we're adding. So plus the limit as h goes to 0 of p of x times g of x plus h minus g of x over h. And then from our limit rules, we know that we can also split these limits up when we're multiplying as well. So then we're going to have the limit as h goes to 0 of g of x plus h times the limit as h goes to 0 of p of x plus h minus p of x over h plus the limit as h goes to 0 of p of x times the limit as h goes to 0 of g of x minus h minus g of x all over h. So now what I'm going to do is I'm going to go ahead and plug in h equals 0 to some of these limits, but not all of them. So I'm going to plug in h equals 0 to this one, so this will go away. And then I'm going to plug in h equals 0 over here, but there's no h there, so it doesn't quite matter. So then what we'll be left with is this will be equal to g of x times the limit as h goes to 0 of p of x plus h minus p of x all over h plus p of x times the limit as h goes to 0 of g of x minus h, g of x plus h minus g of x. This should be g of x plus h up there as well. And this will all be over h. So I'm going to go ahead and zoom out, and maybe you can see what's going to happen next. So let's look at let's look at this right here first. So we have the limit as h goes to 0 of p of x plus h minus p of x all over h. Well, if you look at it, that's all that is our limit definition of the derivative. So this part is just going to be p prime of x. And then doing the same thing over here, we can see that all this term is the limit definition of the derivative for g of x. So this is just going to be g prime of x. So let's look at what we have now. So we have that f prime of x equals g of x times p prime of x minus p of x times g prime of x times g prime of x. So we get that the derivative of f of x equals the product of two functions of x equals the first function times the derivative of the second minus the second times the derivative of the first. So we call this the product rule, and it's also a very helpful rule that we use very often in calculus. And in the next video, we're going to take a look at a couple examples of how to use it. So I hope this was helpful. Go ahead and do me a favor and hit like and subscribe, and I hope you have a great day.